Good afternoon, everybody. We're delighted to have you join us in our second webinar showcasing an incredible highways design package, Site 3D. I'm Daniel Darcy, an account manager at XP Solutions, and we also have with us a team from Wormald Burrows. They really are a brilliant practice who pride themselves in both quality and innovation. For those of you who didn't see last month's webinar, you can find it on our website. We demonstrated a huge advancement in the world of highways design, showing you how to design and edit smooth, compliant junctions and roundabouts in seconds, giving your business a real huge competitive advantage with minimal learning curve. You can find the video on our website under our videos page at xpsolutions.com. So we're back again with XP Site 3D, but rather than show you more of its benefits, we thought we'd do something a bit special for you. We're very lucky to have with us here today Jeff Burrows from Wormald Burrows and also Matt Heaton, Head of Software Development, to run you through a real-life project with you. It's a south of Peterborough bypass and a 2,000 dwelling development. They're going to outline the scale of the project and also the many challenges they faced at each step of the way and how they used XP Site 3D along with great engineering practice to deliver this project successfully. You'll see how they mapped and planned a redesign of a bypass on quite troublesome ground conditions, how they modelled and improved existing infrastructure and roundabouts. You'll also see how to tackle bridges, how they prevented flooding issues, and built innovative sud schemes. And then also, we're going to show you, we're going to touch a bit on BIM. Whilst you watch this webinar, just try and think about what challenges you face when designing highways, and what kinds of novel solutions you had to come up with to solve them. How many iterations you had to go through to get it right, but also what about iterations that just were not possible in the time you had to complete the project. With that in mind, let's get this show on the road. Oh, and please write any questions you have into the dialog box you should see on the right of your screen. We always get back to you and we're looking forward to your responses. With CPD certificates at the end of the webinar, we're going to show you a password. Please remember to write this down and use it to redeem your certificates. You won't get the certificate just for watching a recording of this. Those of you who are watching this in groups, send us a link of attendees, a list of attendees, to our sales email, and we'll make sure everybody gets their CPD. Well, without further ado, I'd like to introduce you to Wormald Burrows, where Matthew Heaton will kick off and describe the project to you.
Thank you, Dan. So in this case study, we'll look at a new development on the southern edge of Peterborough. The city of Peterborough, with its historic cathedral at its centre, is situated roughly 75 miles north of London and benefits greatly from its direct transport links, the A1M motorway, the East Coast Main Line Railway, and the River Nene that runs through its centre. It may come as no surprise that it's an ever-expanding city. So, as part of a major extension to the southern edge of Peterborough, south of Standground, Wormald Burrows Partnership Ltd were engaged to undertake the civil engineering design for a proposed residential development of around 2,000 dwellings with new retail centre and public recreation ground. A major requirement of this extension was the provision of a new 3.2 kilometre bypass to link the south-eastern corner of Peterborough to the Fletton Parkway, a dual carriageway major distributor road that runs from Peterborough to the A1M. This bypass was to have a dual purpose. Firstly, to create a transport link to reduce congestion on existing roads within the surrounding residential areas of South Peterborough and Standground, and secondly, to provide an entrance to the new development. So in this presentation, we shall talk about the following design challenges. Finding a route for the new bypass, taking into account the many site constraints, a new connection onto the Fletton Parkway, dualling the Stanham Way feeder road, the upgrade of the roundabout on the western end of the bypass, a new roundabout on Whittlesea Road at the eastern end of the bypass, the bridge over the Standground Lode, an Environment Agency watercourse, and the bridge over the new bypass. an innovative suds drainage scheme with balancing ponds and reed beds, and the challenges within the housing development itself. So, Jeff, when Wormald Burrows was initially engaged on the project, there was already a proposed alignment for the bypass. You quickly determined that this route was impractical from the point of view of infrastructure constraints and noise implications to the proposed residential development. You therefore considered a number of alternative routes to establish the optimal location of the bypass, accommodating several site-specific constraints.
Good afternoon, everyone. Yes, during the initial project scoping, the existing ground conditions were found to be less than favourable. The geotechnical report highlighted key areas with an upper substrata of peat thicker than 8 metres in places. Quite clearly, this had an impact on foundations and infrastructure construction type and methodology. To minimise construction costs, either a route with better ground conditions needed to be found, or we needed to explore a foundation type that would not require the excavation of large volumes of peat. XP Site's ability to load and display digital soils reports from AGS files was utilised in investigating alternative routes for the bypass. Using traditional 2D tools, this would have been a long and arduous task prone to human error. As you can see here, demonstrated in Site 3D on the actual design model, we were able to dynamically move the bypass alignment and instantly see the depth of each substrata update on the long section. You can see, as I move the alignment, it takes XP Site 3D only a couple of seconds to regenerate the entire 1 kilometre section of carriageway, together with recalculating all interfacing slopes and adjusting each of the roundabout junctions at either end, and at the same time update the long section through all the substrata. This functionality enabled us to rapidly explore different solutions. It became clear that there were lengths of the bypass where the peat could not be completely avoided, and so, in those places, rather than excavating up to 8 metres plus, a design solution was used, producing a reinforced geocellular mat over the peat as a foundation for the carriageway.
Another engineering constraint was that the local water authority had recently laid a high-pressure water main running west to east across the site, which incidentally was not installed on its agreed alignment, the position of which was now very close to the southern edge of Wormald Burrows' preferred bypass route. Ideally, the bypass would be aligned close to the high-pressure water main to maximise the area of the site for the suds infrastructure, Peterborough Road Bridge, dwellings and employment development, but not so close as to jeopardise the integrity of the water main. Jeff, a few metres either way made all the difference?
Indeed, you can see here in Site 3D, we modelled the bypass route with interfacing, that is together with cuttings and embankments, to show the extents of where the bypass would have to be dug in so as to pass underneath the existing Peterborough Road, which was to bridge over the bypass. Because the interfacing slopes are instantly updated with every adjustment of the road alignment, the proposed model could be visually checked against the surveyed position of the water main and adjusted to ensure there was sufficient clearance in the horizontal and vertical planes to leave the water main and thrust blocks undisturbed. This was an iterative design stage, but the speed and flexibility of XP Site 3D enabled this work to be completed very quickly.
The new bypass would link between the Fletton Parkway, a dual carriageway distributor road serving the south of Peterborough, to the existing Whittlesea Road on the opposite eastern side of the site. The bypass was enlarged to reduce the existing heavy traffic flows through stand ground. However, The existing grade-separated junction onto the flattened parkway would need extensive alterations, as it had not been designed to accommodate the increased level of traffic. Jeff, can you tell us how you achieved that?
Yes, indeed. The existing junction on the flattened parkway was of typical design and consisted of 4 slip roads peeling on and off the dual carriageway, connecting to the dumbbell twin roundabouts, one either side of the dual carriageway, with a single 2-way road passing beneath the dual carriageway and joining the 2 roundabouts. Any modifications to this junction would be limited by the bridge, as it would be prohibitively expensive to alter the abutments. A second major limit was the path of the slip roads, these being constrained by the industrial estate buildings to the southwest and northwest, a pedestrian underpass on the western side, and a large lake to the northeast, and the Stoneground Lode Valley to the southeast. To allow for increased traffic, which we wide area modelled from traffic counts, O&D surveys, and movement surveys of residents living on the existing development immediately to the north, our solution was to remove the existing southern roundabout, replacing it with dual carriageway, with signal-controlled junctions for the slip roads onto the flattened parkway. The principles employed in the design of the new junction layout were to replace points of conflict with merging movements, and thus substantially increase the capacity of the junction within the existing grade-separated structure. The new dual carriageway linked through to another pre-existing roundabout 400 metres to the south. So as to reduce construction costs, the existing single carriageway, Stanham Way, was retained as the western side of the new dual carriageway southern link. Modelling the eastern carriageway in XP Site 3D allowed us to minimise the extent to which this new link would encroach on the Stoneground Lode Watercourse Valley and designated Newt and Reptile Reserve along its east flank, by careful attention to various interfacing options in the vicinity of the lode. As you can see here on the XP Site 3D model, as I move the horizontal alignment, everything on the design that is affected by the change is instantly regenerated to show the impact.
The pre-existing roundabout at the southern end of this link, which served an existing industrial estate, would be where the western end of the new bypass would be joining. The introduction of the bypass connection onto this existing roundabout junction would result in a very significant increase in traffic, and so the roundabout required extensive remodelling.
Yes, we remodelled this roundabout in XP Site 3D to increase the capacity of the junction, as well as introducing dedicated lanes for existing traffic to travel to the expanding industrial estate and new traffic to peel off down the new bypass, without either flow impeding the other. Provision was also factored into the design for a possible future Southern Link Road connection from this roundabout. Very severe constraints were imposed on the roundabout design by the presence of the Stoneground Lode Valley, which contains an Environment Agency main river, great crested newts and reptiles, and various depths of peat. Once again, XP Site 3D really came into its own, as all changes to the interfacing, brought about by adjustments to the horizontal and vertical alignments of the roundabout and connecting carriageways, could be instantly viewed in true 3D. The western end of the proposed bypass was connected to the existing roundabout using XP Site 3D's automated junction tools. We defined the existing edge of the roundabout from the 3D survey, then matched the western end of the new bypass to it. This process took only a matter of seconds to undertake in XP Site 3D, but would have taken far longer using traditional tools. XP Site 3D automatically defined the horizontal and vertical positions of every channel and curb line to smoothly transition from the bypass to the existing roundabout.
and the other end of the new bypass, the eastern end, was to be connected to a roundabout junction onto Whittlesea Road. Wormald Burrows had a choice: to pull the route of the bypass slightly further north and connect to an existing roundabout, or break into an existing road with a new roundabout. Following detailed traffic analysis, the existing roundabout was deemed too small to cope with the increase in traffic flows and would have required extensive remodelling. It would also have meant the new bypass route would encroach into residential development land, effectively sterilising a significant area of the site.
Constructing a completely new roundabout in a more desirable location was the only viable solution, but would incur greater costs, which could be minimised by reducing the area of breakout on the existing road. Modelling a roundabout in XP Site 3D is very quick, and this speed allowed us to test multiple horizontal and vertical positions for the new roundabout in order to reduce the amount of work required on site, and while still avoiding the many site constraints, principally the existing bridge, Milk and Water Drove Road, and the old course of the River Nene. Once the horizontal position was chosen, using the 3D view in combination with the vertical road alignments allowed us to tweak the levels of the three incoming roads to the roundabout, two being the east and west arms of Whittlesea Road, and the one being the new bypass. As you can see here in XP Site 3D, the 3D view shows the existing survey surface at the same time as the proposed road surface. So, as the design is adjusted, the engineer can visually see where the new roundabout surface is above or below the existing road surface. This allows control to minimise the amount of burn-off and/or regulating costs required, while still maintaining a 3D roundabout surface that met the required standards and drained efficiently.
The ability to immediately generate a roundabout design in full 3D that complies with all design standards, with even gully positions located correctly in accordance with the British standards and the DFT Roads and Bridges standards, underscores the step change between XP Site 3D and competing software. The difference is twofold. XP Site 3D has been designed from the outset such that every construction entity understands its relationship to other entities, which is the essence of BIM, Building Information Modelling. And secondly, XP Site 3D has decades of design engineer intelligence built into the design processes. The result is a design that would previously take a day or two to complete can now be undertaken in seconds, in real time, with design standards met. So two new bridge structures were required. The first to enable the bypass to cross over the stand-ground load watercourse, where the Environment Agency stipulated that animal movement should be accommodated throughout the length of the stand-ground load. This necessitated the inclusion of a berm and greater dimension between abutments to provide free passage at top of bank, and a second bridge to allow the proposed bypass to pass beneath the existing Peterborough Road.
XP Site 3D was used to design the carriageway over the stand-ground load bridge, and from this design a general arrangement drawing was prepared and passed to the structural engineers for the structural detail. Similarly, a new bridge was required where the bypass crossed beneath Peterborough Road, where the same process was repeated, with the bridge structure being modelled in part using XP Site 3D. The interfacing tool was used to outline the bridge structure and void beneath in 3 dimensions. One great advantage of XP Site 3D is its ability to model in true 3 dimensions, where one road, in this case Peterborough Road, crosses over another, that is, the bypass, allowing the engineer to accurately create vertical alignments for both roads whilst maintaining the required vertical gap between the two. It was also at this point that the bridge severed two large diameter foul trunk sewers that drained the settlements to the south of Peterborough. Modelling of the foul water drainage solution was undertaken in MicroDrainage using the direct link between XP Site 3D and MicroDrainage.
The Drainage Authority, the middle level commissioners, stipulated that the on-site stormwater drainage scheme at Standground maintained high standards in water quality and efficiency. As the old River Nene was pumped, the middle level commissioners required a £56,000 surcharge per impermeable hectare of development, which for 40 impermeable hectares of development amounted to £2.24 million. It was agreed with the middle level commissioners that if a scheme could be designed to at least replicate, if not improve upon, the runoff regime of the agricultural land, that the £2.24 million surcharge would be waived, but that the design had to fulfil criteria for stormwater outflow to replicate the greenfield runoff in terms of time of concentration, quantity and quality. To achieve this, Wormald Burrows Partnership devised an innovative SUD scheme, making use of the grassy public open spaces between the houses and the noise abatement land strip alongside the new bypass, whilst simultaneously improving the aesthetics of the residential development. Jeff, could you describe how Wormald Burrows achieved this?
Well, as part of an agreement with the Water Authority, we had to ensure the stormwater runoff from both the residential development and the bypass had to pass a certain quality standard. To reach this standard, the water would have to pass through some sort of water treatment system to remove pollutants and impurities, to ensure that it would be safe before discharging into the river network. It was imperative that a low-velocity attenuated flow was fed through the reed beds to ensure efficient filtration before the water outflows to the River Nene, and this was achieved by using a series of ponds located between the bypass and the development. We designed the reed beds in XP Site 3D by modelling a series of shallow, fairly wide earthworks aligned along the existing ground contours with raised ground in between to enable future maintenance, and this produced a combined flow distance of about 1 kilometre within a relatively small area of land. This required that each reed bed had a minimum form, with a 10 metres long weir at the downstream end of each reed bed. Water from the balancing or attenuation ponds discharges beneath the bypass at a set rate and enters into the receiving reed bed, then slowly flows along it before passing over the weir, discharging into the next reed bed to flow in the opposite direction onto the next bed, and so on. The process ensures the reed beds have plenty of time to filter out the silt and other impurities before finally discharging into the River Nene. The replacement of sterile agricultural land with reed beds provides significant environmental and wildlife habitat benefits. An additional aesthetic benefit by designing the reed beds aligned to the existing ground contours is that when viewed from eye level, it appears as a single large bed of reeds, which adds to the visual appeal when travelling along the bypass and at the entrance to the new development.
And the on-site swale networks between the new housing have been designed to not only attenuate the flow, but also to act as a water treatment system, whilst the water has been directed away from the properties towards the balancing ponds. These balancing ponds then attenuate the flow by limiting the outflow to the reed beds, and hence to the River Nene, and providing sufficient storage for the critical storm.
We used XP Site 3D to design the swales and piped stormwater system into the 3D model, which could then be easily exported into MicroDrainage to run the drainage simulations. The results from the MicroDrainage simulations were then fed back and used to determine the critical storm event, which then informed the engineer the volume of storage that would be required in each of the balancing ponds. Using the pond tools in XP Site 3D, it was very quick and easy to model the attenuation balancing ponds that are located between the southern edge of the housing and employment, development and bypass. The layout of the development and the topography determined the positioning of the balancing ponds, which were placed either side of the main site entrance, adding to the visual appeal as residents enter the development from the bypass. And the area benefits from the greatly increased flora and fauna as compared to that which was there previously. There was a further benefit arising from the method of treatment of the stormwater discharge. Under the Code for Sustainable Homes in force at the time, the stand ground development gained extra credits as it fulfilled the criteria which specified that a typical 5mm rainfall event would provide no additional flow off-site. The long swales and balancing ponds throughout the residential development, in combination with the reed beds, allows the 5mm storm event to soak away, be absorbed, and naturally evaporate, and so never actually reach the River Nene outflows.
As mentioned earlier, construction of the bridge that carries Peterborough Road over the bypass caused 2 foul trunk sewers to be severed. Because of foul water surcharge problems downstream, it was necessary to introduce buffer storage. Additionally, the Water Authority required that each of the trunk foul sewers downstream of the bridge should take similar flows as were being delivered before they were severed. How did you address this challenge, Jeff?
Well, there was a proposal by another consultant that the only means of meeting those criteria was by constructing 3 pumping stations, 1 for each of the trunk sewers and 1 for the foul water drainage arising from the new development. Each of the pumping stations was to have consisted of 3 chambers, each of 4 meters diameter and 8 meters deep, in order to provide buffer storage, constructed within well over 12 meters depth of peat in that particular area. For obvious reasons, that consultant was having great problems in convincing the Water Authority that the scheme was viable and that the Water Authority should adopt the 3 pumping stations when completed. With negotiations at a stalemate, Wormald Burrows proposed an alternative solution whereby a single pumping station could be utilised at a maximum depth of 4.5 metres that would provide more than sufficient buffer storage. We designed a novel but simple means of delivering proportional flows. The basic parameters were then modelled in XP Site 3D and, using the link to MicroDrainage, proved the efficacy of the proposal. Although the pumping station design did not conform to standard practice, the Water Authority acknowledged the advantages and adopted the principles of design, and have since, I understand, utilised that design in other problematical pumping stations when balanced flows are required. The net result of this proposal, modelled using XP Site 3D and verified by MicroDrainage, was a saving to the developer of close on £1.2 million and a solution that was adopted by the Water Authority.
The main function of the on-site storm drainage is to protect houses and other buildings from potential on-site flooding arising from extreme rainfall events. And yet, conversely, the site also needs to be protected from the floodwater should the River Nene flow out of bank. Wormald Burrows devised a means of reducing development costs by designing the bypass to perform as both a flood barrier to the River Nene and as a long weir by which, in extreme rainfall events, excess on-site floodwater could escape from the site to the reed beds, flowing at minimal depth across the carriageway.
To achieve this, the vertical alignment of the bypass was adjusted at the lowest point to ensure that the low point was 600 millimetres above the highest known previous flood level and producing a long weir. Modifying the vertical alignment of the road is very quick in XP Site 3D and automatically recalculates any and all features that are dependent upon it. The real-time adjustment of horizontal and vertical alignments is a powerful tool for the design engineer. It saves time and removes the possibility of human error. The interfacing and contouring remain up to date and instantly show when the design has achieved the desired level to avoid on-site flooding. Thus, under any flood conditions, the on-site flood routing ensured that, if the drainage systems were overwhelmed, all properties would remain above flood water flows.
Let's take a look at the residential development of the site. A quick review of the on-site design shows the numerous quirks and challenges of the architect's road layout, all of which have presented no problem for the engineers to design speedily and accurately using XP Site 3D. Here we can see amorphous shaped roads where the left and right channels are anything but parallel or straight, turning heads of various individual designs, numerous standard road junctions, non-standard road junctions of various shapes, widened road bends to allow larger vehicles to negotiate the bend, raised road surfaces to provide a shared surface for vehicles and pedestrians, road narrowings for traffic calming, cycleways and footpaths, roundabouts, playing fields, and public open spaces.
It is interesting to see just how accurately the built site matches with the 3D design produced from XP Site 3D. The files can be output in a form to be used by the surveyor or contractor for direct input into their instruments or plant. In the early days of the stand ground project, this was in fact the first job where the surveyors requested setting out data in digital form to load directly into their instruments, though this is now a common request. Another great advantage of XP Site 3D is that it is intuitive in operation. A number of our engineers have picked up the program with little or no training and, within a day or two, have been a reasonably proficient and productive user. From the employer's point of view, I find that engineers are more content when using XP Site 3D, not only gaining satisfaction from the amount of work that they can produce, but knowing that the final result is fairly well honed and a better job all round.
Finally, we should quickly talk about BIM, Building Information Modelling, which has become a hot topic in recent years. And if you're working with a UK government body, it is becoming mandatory to be BIM compliant. When development of XP Site 3D was started from scratch around 12 years ago, what is now called BIM was preempted by designing the software around the principles of intelligent objects. For example, Site 3D knows a road is a road, and it knows how a road interacts with its channels and its curbs, and how it interacts with other roads and footpaths and houses and so forth. This is what gives XP Site 3D the ability to automatically and instantly regenerate everything on the design when you make a change to any element, all based on sound engineering principles. So you can export your design in BIM format to be included in the BIM model. For example, commonly Navisworks may be used to collate the BIM model for the extended project. Here we have the Peterborough site in BIM model format viewed in the Celebri viewer. You can see that the BIM model contains everything from the XP Site 3D design and looks identical. So that concludes our part of the presentation today. Thank you for attending the webinar, and I'll now hand you back to Dan for some final words.
Brilliant, guys. Thank you very much. What a fantastic live demonstration of not only great software, but more importantly, great engineering. And that's really what it's all about. It's the reason most of us are here today, to solve problems and to create elegant and novel solutions for real-world challenges that will improve the livelihoods for us all. A really big thank you for the team. Thank you guys at Wormald Burrows for sharing your story with us today. If you could just pause and remember back to the start of today's webinar, I asked you to think about what challenges you face. We'd love to hear you share them with us, and that will enable us to better understand how our technology can help you. Any questions or any information you want, if you're interested in XP Site 3D or any other products, we'd love to talk to you. You can either call us or email us at uksales@XP Solutions. Just a few bits of news for you very quickly. We're in Ireland on the 1st and 3rd of November. We haven't been there for a while, so we thought there's a lot of interest. The industry is doing very well at the moment. Let's go over and do some MicroDrainage training and get everyone up to speed. Also, we're in the NEC event London tomorrow. Myself and my colleague Ludmilla will be there. So if you're there as well, come and join us. We'd love to talk to you. And yeah, so thank you very much for joining us today. Any questions, just ask. We'll reply to you all, but thank you for attending today's webinar. Thank you very much.